Well, hi there. This is video number 30, and it is our last chapter of the year. So this is chapter 6, section 1, and it's actually sections 1 and 2. There's a total of 36 videos. So we have, after this one, there will be 5 more. And this whole topic is about square roots. And today, well, radicals and square roots, because some are cube roots and fourth roots and other things. But this one is about simplifying square roots. Okay, and we covered a little bit of perfect squares and that kind of thing in our formula where we factored square roots. Here, your goal is to break down the value under the radical sign. That's called a radicand, by the way. The radicand is the radical sign. Break down the value under the radicand to its lowest terms. And I just want to talk about the calculator a little bit. If you see something like the square root of 20, do not put this directly in a calculator. Okay, if you do, you're going to get a decimal value, and that's not what we're looking for these. Your answers should have, unless they're perfect square, your answers should have radical values. Should still have radicands in them, unless they're perfect squares. So you can use your calculator to do multiplication for you if you don't know what factors of a number are, but we are going to use factor trees to do this. And you should know that when you use a factor tree, we're dealing with multiplication. So we're using multiplication. And often you want to break down to prime numbers. Remember that a prime is a number that is only divisible. So it's a number divisible, which means evenly divided by 1 and itself, like 5. Okay, so what we're going to do is use a factor tree and then talk about how to simplify these things. So let's start with this root of 20 that's up there. I'm going to take and factor that, make 2 little feet, and I'm going to factor into 2 factors of 20. It doesn't matter if you pick 2 and 10 or 4 and 5. I'm going to go with 4 and 5. And anything that's not prime, break down further. So 5 is prime, 4 is not. So I'm going to go radical 2, radical 2. And I like to then cross out anything that is not prime. So I'm going to just cross out that 4. All right, and then here's your goal. Excuse me. You can pair up, and put this somewhere on your paper. Pair up, which means 2 of them in a square root, radicals, to remove the square root sign. So here's what I mean by that. A radical 2 and a radical 2 is a pair of rad 2s, and they create just a 2 with no radical. Okay, so you can pair them up, which means 2 of them, 2 sets of radicals to remove the square root. So you get the value without the radical. Okay. So it needs a buddy to get out of jail, so to speak. And then if there is no buddy, like there is not for the rad 5, then your answer is whatever comes out of the radical times whatever's left in the radical. So the root of 20 is equal to, the root of 20 is equal to 2 radical 5. The 2 radical 5 being your answer for this problem. Oh, I was hoping that was yellow, but you get the idea. All right, let's do another one. The next one we're going to do is we are going to break down the root of 48. Okay, so I'm going to change my color, and I'm going to go rad 6 times rad 8. Please take the time to write out the small radical symbols. Here's what I mean. Don't go rad 48 is 6 and 8, 6 is 2 and 3, because it's hard to remember what has a radical and what doesn't. So don't do this. Make sure you're putting little radical symbols over these. So 6 is going to go to 3 and 2. The 6 is gone. The 8 is going to go to 2 and 4. The 8 is gone. The 4 is going to go to a 2 and a 2. And the 4 is gone. All right, so now, remember, I can look for pairs. And so I have a pair here that becomes A2. I have another pair of 2s here that become another 2. And so I want you to think factor trees mean you're multiplying, right? So we're going to take any number that comes out of the radical and you're going to multiply them together. And then anything that stays underneath the radical, if you had more than one of them, they would also get multiplied together. So this is equal to 4 radical 3. Okay. Let's do another one. Let's do 120. I'm looking for one that's got multiple factors to it. So let's do the root of 120. And I'm going to go 12 and 10 because that's what stands out to me right off the bat. My 12 is going to go to a 3 and a 4. My 10 is going to go to a 2 and a 5. The 4 is going to go to a 2 and a 2. All right, so here's an interesting scenario. Look what's going to happen here. These two can pair up and give me a 2. But I have all of these that don't match up with any. And so you're going to end up with this 2 down here, that 2, radical 2 times 3 times 5. That's all the numbers that don't pair up with anybody. So we get 2 radical 30. Okay, so you can multiply things underneath the radical if they're left over. You can multiply things in front of the radical if they're left over. And sometimes you have to do both. All right, so as long as you can break these numbers down, they're not too bad. Another thing that might happen is you might see something like this with a coefficient out in front. You might see 6 radical 40. Well, this 6, you do nothing as far as breaking it down. You just leave him alone because he's not under a square root. So we're going to kind of leave him alone for now and only deal with the 40. So this is going to be rad 4, rad 10, rad 2, rad 2, rad 2, rad 5. And I can't go any further. So these will give me a 2. And then what's going to happen is this guy's going to come down. You're going to multiply this guy. And then underneath your radical, you have these 2 values. And so this is 12 radical 10. Okay? So if you have a coefficient out front, it just comes down in the problem and you leave it alone until the end. Multiply it by anything that comes out of the radical, and you're good to go. All right. Real quickly, let's talk about reducing variables. And this is pretty straightforward, and it works similarly. If you have the root of x squared, essentially you have a rad x times a rad x, or you could do this. X squared is x times x. You pair them up, and it would come out of the radical, And so the root of x squared just equals x. Okay? If I have the root of x to the fourth, well, I didn't need that radical to be quite so long, then I can rewrite that, if you want to, as x times x times x times x. You have two groups of x's, nothing left over under the radical, and so this is x squared. Okay, what if you have x to the fifth? The root of x to the fifth is the root of x times x times x times x times x. There's two groups of x's, so that's x squared, and this guy can't come out of the radical, so this gives you x squared radical x. Okay? All right, so the last thing we need to do is take a look at what happens if you combine a number. You have 240, x to the third, y to the second. And so if you do this and you get a number in variables, I think the best way to handle this is to break this up into, in this case, 3 different radicals. So here's what I'm going to do. I'm going to take the root of 240 x cubed y squared, that other stuff's in my way, and I'm going to go the root of 240, the root of x cubed, and the root of y squared. So if you have multiple variables, just break up however many you get. And then do the number. So this is 24 and 10. 24 is 6 times 4. 10 is 2 and 5. 6 is 3 and 2. 4 is 2 and 2. Those are all gone. Okay, that's done as far as it'll go. My x cubed is x times x times x. So this groups together. This won't come out. And then my y is, and those group together. All right, so let's go back to the green. I have a set of 2's here, which give me a 2. Another set of 2's here, which give me another 2. And a rad 15. So if you do each of these individually, 240 comes out to 4 rad 15. The x to the third turns into an x will come out because of those two, and an x will stay in. And for the y's, you have one group, so one will come out and you have no radical. Now you just combine everything. Anything out front will stay out front. So you have 4xy, and anything under a radical stays under a radical. And this is your answer. Okay? Those aren't too complicated. They just take a little bit longer. The one other thing I do need to tell you is that in varsity, there are some instructions, and I'm going to tell you this is in 6.2, questions, I think 9 through 16. Yes. You have to make sure you read the directions for these problems. Part of the directions, it says, it ends with, do not assume the variables represent positive numbers or something like that. And it's really this do not assume. So if that's in there, here's the deal. If you have, let's say, the root of y squared, you don't know if that's a positive y times a positive y to give you a y squared, or if it's a negative y times a negative y. Both of those equal y squared. So if you can't assume they're positive, when you reduce that value, the variables that come out of the root must have absolute value signs around them. Because you don't know if it's a positive or a negative. So let's go back up to this answer right here. I've already done the work, and you're going to do the work just like we did. And if the directions say do not assume that the variables are positive, you're going to take and put absolute value signs around any variables that come out of the radical. Okay, they have to have absolute value signs around them. So I know that there's a problem. It starts out with something really straightforward, like the root of 36x squared. Well, you can look at that, do no work, and know that that's 6x. But if you put this in as your answer, you're going to get it wrong, because the directions say do not assume, which means you need absolute value symbols around that x. Okay, so 6 absolute value of x. This is the correct answer. And like I said, that happens in 6.2. So here's what's happening. 6.1a is 10 problems just reducing radicals. 6.1b is another 10 problems just reducing radicals. And then 6.2 has variables added to it. Okay? So these shouldn't be too terrible for you, I don't think. I will see you in the next video. Toodaloo!